All right. Hello, welcome back. How you doing? Hope you're well, and if you're not, I hope you will be soon. I'm Agent Ultra. This is my little stream, and on the stream I like to do functional programming. Mostly in a language called Haskell. I don't know if you've heard about it, but it's pretty cool. And for the past little while, I've been working on a little project to try and see if I can build a multi-user dungeon, a multiplayer online game. It's text-based, but kind of real-time-ish. And yeah, go see how far I can get with it, what we can learn with it, and have a little fun, and build stuff. That's just what we do here. I like to hack on things. Yeah. So without further ado, let's get to some code. Yeah. What did we do last week? We got the starts of an entity component system going. I'm not sure if that's the best place we should be working on things right now, but that's kind of where we're at. Just trying to put together some mobs and stuff. And I was just thinking, like, I should probably actually like have rooms and things too, you know, for the players to move around in, and for the mobs themselves to inhabit. We need a place. But, yeah, so I don't know. We'll figure it out as we go along. That's what we do. It's mostly a simulation. So, component part, we're working on components, and instantiating components, and defining components. So we're working on component definitions. And the idea was that we want to be able to define the user when they're defining their MUD code and like all the different components in their system. We want to be able to define what the components are. Like they're like a block. Like, and we're writing the parser for it. I don't have an example yet, but let's just pull up a little buffer here. And what we were kind of going for, and I don't know if we should change our mind on this, but the idea would be like you define some keys. Your component would have like a name. All right, let me bring the, where's the video definition parser? Excuse me. Yeah, it would have a name, a label, and yeah. So we'd have like a label for the component, like maybe it's a health component, and maybe it's got points that's like an integer, and like a status, that's maybe like a string, something like that. Now, I wanted to be able to keep this all written in, like all the MUD code written in Lua as much as possible, just for consistency and making things easy. So one of the things I also wanted to look into was if the Lua library that we're using can actually like parse the Lua code and give us back an AST or a structure that we could use. So that you could write the definition in Lua, and then I don't have to parse everything custom like a DSL. I know we can call Lua code, but I want to know if we can parse Lua code. Which I don't think I don't know if we can really. We have Lua types. A Lua bool, but these are returned by the C API. So this is all runtime stuff. So Lua can return data to us in Haskell land. Which is all good and dandy. No, sorry, not source contents. Primary user data lib. This Lua library stuff. Warn. Ersatz. Get functions. Set functions. Get table. Behaves like Lua. Get table. Prevents. Let me just see if there is. Oh, there's a language dash Lua. Parser and pretty printer. Okay, this is good. Relatively new. Should work with our stuff. Okay, this is what we need, maybe. Sweet, okay, cool. So we got the parser. And we get either source range string or a block. Okay. So a block is a list of statements with optional return. We got assignments, function calls, labels. Break, go to, do, while, repeat. If, for range, foreign, find assign, local, find assign. Empty stat. Okay, that's all good and dandy. Parse text stat to parse statements and parse text expressions to parse expressions. Okay. It's promising. Stat, a parser of stat statements. Okay, expressions. An expression, a nil. I think the expression is probably what we want. Table constructor. Okay, this might be better. This might be better because this would allow us to do. I don't know what that's all about. This might allow us to do something like we could define it entirely in Lua. Do I have a Lua mode? I do. Alright, and then we could do our own fields, like health. And we could stringify the things. We still have to type check this when we parse it in Haskell, but it might be more consistent and easier for people to use. Alright, you give me a component like that, or you can even name it, you know, health component. Something like that. Alright, we can parse that table field probably. Or as a statement. So expressions we get new. Okay, sorry, statement. We got assign. So we get the assign var, we get the variable name out. And the expression, then we can get the table const. And it goes through the structure and build up our definition from that. Instead of having a DSL, that actually might be pretty useful. All right, I'm going to create a little branch for this experiment and try it out and see what happens. Little parser. Okay, let's go to our Cabal file. And we're going to add language-lua. And it's going to be probably whatever the latest one is. 0.11.02. Keyboard adjustment here. Here we go. Yeah. Okay, let's get GHCID running. Okay. So while that's building, let's go over to component. So we will get rid of the parsec stuff. Okay. We will add the HS or the language Lua. So we need parser. I'm going to pop over the REPL and just play with it a little bit. Parse text. We gotta give it a parser A, so stat. Now we'll bind it to P. And then we give it a string or text. Yeah. So let's do our example health component equals, and we're going to make a table points and status. This is actually the right Lua syntax. We have to escape these. Escape that. That. Okay. Okay. Yes. We're gonna have to X. Overloaded string. Oh, what is it? It has set. Overloaded strings. There we go. There. Okay, so what do I got? I got a left. Okay, yeah, that's not the right Lua syntax. I think it's equals sign. Still got a left. Oh no. Oh, jeez, what am I doing? I want, like, health component. Okay, I'm gonna have to be silly and look this up. Lua syntax. How to write? Yes. Tables, not functions, strings, arrays, tables. is dictionaries. Days equals dictionary days. Constructors. I guess we gotta put them in these little braces. Alright. Whatever the case may be. Points. Int. And status. Let's call it stir. Like this. Yeah, so let's put a little bracket there, a little bracket there, bracket here, little bracket here. There we go. So that's the structure we get. We get a right and a sign, the var name, both component. So we can pull that out and make the name of our component definition that var name. Then we have a table const with a list, it looks like, of our fields and their values. So we could parse this out into our structure in Haskell using this. And I think we will be pretty good. So let's go and see if we can make this happen. We're going to import language.lua.parser. Yes, it's redundant for now, but we're going to parse definition. All right. Parse definition. What's our input? Say text. What's our output going to be? Either it's going to be, what is the error normally thrown by parse text? This source range string tuple pair. So we could probably just do that. Where does that come from? Annotated lexer. A parse error. Source range and string, I think it was. Already qualified. Just keep our namespace a little clear. Hopefully the namespaces are okay within either. So we'll go either Lua parser or we get our definition. We'll get the, they call it label, value, component values, component type check. We'll get like the text and the definition. So the text will be like a label. the types. Cool. So the first thing we'll do is we'll get our parsed Lua code. What do I call it? Parsed? Parse text. We need the statement one and our Lua code. Okay. Next, once we have parsed, we know we have an assign, and we need to check what we got here and pattern match out the data we want. So the only one we care about is assign. Now assign has a couple parts to it. Yeah, two lists, variable and XP. So the only one we care about is when we have var name, and that's that. We don't need the parentheses there. Then we need another, the table const definitions. So the table const will match on that, and then the fields. We'll do some further matching on that. Otherwise, we want to turn left. What are we going to do for source range and string? The error type. Maybe we don't want Lua parse error to be exactly this. Maybe we just want it to be component parse error. Component definition error. And what's a component definition error? It could be a parse error. Where we could have the Lua source range and string, or it could be a component definition type error. And I don't know what to put in there yet, so we'll just leave it until we get to that part. A little econ show on there. Okay. So if this here, we get left, we can do left component definition. This could be parse error too. Parse error or component definition interpret error. Like that, maybe. And we'll do left component definition interpret error. Maybe text. We need a better error system for this, of course. This string is just going to be a placeholder. Okay, so we pattern match out the assign, we get the variable name label, and we get cost fields. That should be enough to give, the label should be enough to give us our text. And then we have to come up with a definition, which is to build up a map of text to D type. Okay. Which is going to be mapping over the fields, essentially. So we're going to... We're going to fold those fields. That's what we'll do. Yeah. Fold takes our function to fold our accumulator. Build definition. Our base. Empty definition. And over fields. And that's going to be that. It's going to be def. That's yeah, definition. And then we don't even need this to do, I don't think, because we'll just go in and we'll go label and def. Okay, so we gotta bring some stuff in the scope here that we don't have yet. This is gonna change to component definition error. Sign isn't in scope. That comes from Lua syntax, language.lua syntax. So let's bring that in. Okay, we can't do this line here on 50 anymore because this either needs to match the same either that we're gonna, any of these binds are gonna return. We could fmap over that to get it to be the kind that we want it to be. So we're just gonna let bind it. And then parsed is no longer going to be unwrap for us. Unwrap. So we could hop it over here as right. And we need data.list. And then we build definition in scope. Okay, one of the things I'm thinking about here now too, that we've done, the let binded the things, we probably should pattern match a little bit more on different cases. to get the better errors. Because if we get the left, we can actually return the definition parse error just like that. So let's do that. So we will return left component definition parse error. We're gonna have to put a little beep in there. And we still have some unmatched cases to handle, like write anything else. And that could be a component definition interpret error. Valid Lewis definition. To do better error message. Okay, that's a little better. And now build definition. Let's put that in scope as well. We'll make it a where binding here. So we're going to be building up a map of text to D type. We're going to get a exp field, which I think is a stat table field, sorry. A list of table fields, or a single table field. And we return a map text D type. Now there's going to be, I think, one other thing that this is starting to stand out to me with this design is the mappings of D types. We're encoding them as Lua strings in our example here, and we're going to need to parse those into D types. What can parsing do? Parsing can fail. So our fold isn't necessarily going to work unless we fold into an either type, something like that. Let's just fix this other type error here because that's pretty simple. We'll get back to that. An empty definition. Is a definition. And we just kind of do that. All right. Oh, sorry, empty definition map. Oh, we don't need empty definition. We just need empty. Right. So, I think to fix this, we're going to have to do something about that. If I turn this into a bind, and an fmap, turn this into a do. Okay, on 54 now, we couldn't match type, map text D type with either component definition error or map text D type. yeah, the f map there isn't gonna. Actually, what would the whole value be? Something to definition. Because it doesn't know what we're trying to build up from full del prime. That's right. But if I give it a type hint, it should be a definition. Yeah, I think it's going to need scope type variables to actually work. No? Mm-hmm. That's okay. Type applications. Type foldable T B. Yes, the second one. Okay, so the whole now is going to be D-typed definition. Interesting. Yeah, it's call it def map. And then we can just do definition. Like that. There we go. Okay. Now, on 55 def map, we have we want it either component definition error to D-type, otherwise, or map to D-type. No, we don't want to D-type. Let's see if the type applications are confusing. There, that's better. Okay, so we're going to move away from fold L prime now to traverse. Takes our function, the thing we can traverse over, T of A. Okay. First our function. Let's go to change type. We'll leave it off for a minute. And then fields. Okay. So now it wants us to write a function, Lua table field, to either component definition error or D-type. I think we can do that. Did I mistype that? Oh, it's just, I must have scrolled by accident. 56 there. Okay, traverse isn't necessarily going to work. Because it's returning a list of D types. We want it to build up a map. We want our T to be our... Well, it's because we're traversing over a list, so of course we're going to get a list of that back. Okay, so... we're going to transform you into a map. We could transform the fields into a map, traverse over that, and just do our parsing. And we probably want to use the maps traverse. Yeah. Okay, so this will be traverse with keys. And fields. We'll do a field map first. Field map. Traverse. We're gonna do something over fields. We can parse the field. We get the depth map by traversing again with maybe get field, parse fields, a field map. Only this would be map dot traverse with keys. Now we'll get rid of that. Traverse with key. Traverse with key. Does that work? Get field. fill in some types. Be a Lua table field, either component definition error or what would be? Could we do map text? Text? Get field. And then parse field, it wants it to be a text to map text to either definition or D type. I don't know if that makes a whole lot of sense. Yeah, okay, so 156. Yeah. Haskell's saying this doesn't make a whole lot of sense, which I agree. The types just aren't stacking up right here. Should be a pretty straightforward transformation. This is a list of these types here. EXP fields. That's what we want it to be when we're parsing this thing. And they're going to be strings. They're all strings. Pairs of strings, really. So if we turn those into pairs of strings, okay, then def map. In fact, we could even make this string D type. And def map just becomes equals from list field map. In fact, we can put constructor on it as well. Right, and then this error here. String D type. We want it text. Oh, because our, yeah. So we need to map it to text. D type. Okay, that's good. Haskell's happy with that, roughly. Some minor things here. Error is shadowed. Parse field never used, yeah. Okay. I think that looks a little better. Okay. So let's get our table field here. Let's see, the table field, we want to match on table cons or exp field. Exp field's the one we care about. And we want the string name and string val. The Lua dot. Okay, cool. And then we get an either hole there as well, which is nice. Okay, so in order to build this tuple, we will need to parse field type val. I'll call that d type. And then if that works, we get your text.pack name and d type. This will be a do. Okay. We have to import data types qualify. Okay, parse field type isn't in here, so let's do that. It'll be a string to d type. No, either. Component definition error or d type. So we know int pure d int. We know stir. Stir. I think that's it, right? D string. And then the other one we decided to try was num. There will be others. Otherwise, we have to have a new component definition error. The type error. We'll make a text. Unknown component definition type. Text pack other. Lua string. Oh, just string. Okay, what was I? Expected string, actual text. Okay. We don't actually have to pack it. And here. Oh, that should be left. Oh yeah, the rest of the get field. So anything else with get field that doesn't match this exactly, we don't care for. So we'll return left. component definition interpret error. Valid Lua field definition. To do better error message. Okay, there's our parse definition there. So we're parsing right from Lua, hopefully. Let's try it out. Let's see. Health component equals points. Int and status stir. Okay, cool. For some reason, we got unknown type. Oh, you must have. Yeah, I must have done something weird here. Because that won't parse in Haskell land anymore, will it? No. It's looks to me like it's feeding in my backslashes. Okay. Maybe that's actually Haskell escaping everything like it should be, but well, if I give it the empty string, we should get a parse error. Same with that. That's good. Oh, that parsed. So that could be the empty component. That actually would be fine. Right, invalid Lua definition, that's right. That's right. That's right. Weird. Let's do a little debugging. Okay, it's literally getting with the quotes in it. That's why. There we go. So we're gonna strip those off when we're parsing. I'll just call it strip name. Okay. Then I just have to figure out how to get the text with the end stripped off. There's got to be like a function for that. Not this white space though. Yeah, we could drop while, I guess. Or drop around. Yeah, there we go. Is quote. Data.car. Probably has the function I'm looking for. Number punctuation. That might work. Might be fine. I'm just thinking, like, there's other Lua strings that might be valid in there. Like, I wonder if, like, it'll probably peel that little tick off if the user meant to have the tick in there as part of the name for some reason. Otherwise, there's literally any character, just the first and last. Is printable. Yeah, that's so same. I don't know, let's just do is punctuation. And drop around data.text. There we go, that's better. Okay, let's get rid of debug. Sweet. That's gonna be nice. That'll be nicer. I'm glad we found this. Parsing the Lua source, and that way everything can be Lua files. Yeah. So component definitions just have to be formatted a certain way with a certain convention. But it could just be plain old Lua definitions. I mean, our DSL might have been like more terse to run, but whatever. We probably could even get smarter with the parsing, so that if you wanted to, you know, this is pretty verbose to write, I imagine. But there was a couple examples from the Lua tables where you might write it a little differently. Like you might write my table like this, but then use assignment to add the values. I think we're gonna have to settle for the parser approach. Because I don't have to interpret the Lua code for these definitions. So, well, hopefully this will be not too bad for folks. Cool. Stir. We get a D string. Num. We get a dnum. D's nuts. Nothing. Right. Okay. Create a little committee commit. So let's commit. We'll modify Bakamud simulation component. Added language Lua dependency. And a definition parser. Component definition parser. Lua-based component definition parser, yeah. There. Sweet. Okay, so now that we can parse our definitions, what do we need to do now? We parse them. We can instantiate them from the definitions too, so we can parse those definitions. We have a way to instantiate them with some component values to get an actual live component. That does all the type checking, everything. Very basic stuff, but still. More like type matching. What about rooms? I want to get to a place where we can connect to this thing, we can log in, and we can get the first room displayed, you know? Okay. So, the entity component system is going to be for entities, mobs, things that move around in the world, items, things that the user can pick up and put down and use, and all of the objects that inhabit the simulation. There's one object that is kind of special, and that's the place, the universe in which the user inhabits things. So, typically, a lot of multi-user dungeons and MUDs were room-based, often laid out in a grid, or something with like cardinal directions of some kind. They weren't necessarily all grids, but like some of the early ones might have been just like, I just had north, south, west, and east. Right, then you can have a room here, and so on. This might be like a very, very simple map, but that was the idea. Just a grid. We did a text adventure engine a while ago. Text-based adventure. It was a single-player ordeal. Similar concept. All right, we have an exit. And the exit is what connects the rooms together. But, well, not a but. Some MUDs evolved, and they might have more cardinal directions. Right, maybe they have northwest, northeast, southeast, and southwest. Maybe they even have, like, Gugugaflats and off to somewhere far away in a different land. Whatever the case may be. I think the overall structure is still kind of the same. Right? These exits are what combine together rooms. Yeah. And rooms are like they'll have some kind of description, some kind of flavor text for describing the scenery, what the player's avatar can see, in terms of like just the structure of the room. But then there's going to be like the objects within that room itself. So the room's also kind of like a container. Right? It can contain players, avatars, and items and objects of all sorts. Mobs, actual objects that the player can pick, the player's avatar can pick up and put down, throw and do all the things they need to do with. We could maybe look at doing this in Lua as well. It might get a little verbose, but we could do the same strategy we did for components for defining rooms and exits. It'll be a little bit more tricky because we have to parse those values from the user code, and then we have to actually try to construct a sensible map structure on our side so that when we want to move an object, a thing, an avatar, a mob, an object from room to room, alright, we have a way for the user to the system to do that somehow. Well, we're gonna have to have something like that in some respect. A way to move, say, avatars. Right. If there's an avatar here, it's connected to a user's client. On their computer. Alright. They're probably going to send it a command to, like, go northeast. Right? Or go to the exit. And that's going to be fairly universal for almost every MUD. Right, go to the exit. Go here, go there. Move around the map. Now, we could... Well, we want to be able to have the MUD code decide what to do when the user sends a command. That isn't one of the server commands, like login and authenticate and those ones. But do we want them to have to handle, like, in their own code, in the MUD code, like moving users from room to room, moving avatars from room to room. The users over here happily at their computer issue commands. I'm thinking maybe we should have like an API that we give to the mud code on the Haskell side to say like move the user or move the avatar. Sorry, move the avatar. Yeah, to this exit, or try to. All right. So that you can implement your own movement code in Lua. But to actually do the movement, to tell the server where this avatar is, because the server needs to know that in order for our code on the server side to stream to the client, what do they see and what do they see happen. Yeah. So I think that's probably the way to go. Is define these things on the Haskell side and then provide an API to the mud code for updating the state of these things. But you give us, in the mud code can give us the definition of those rooms though, and those exits. We'll just have a structure on the server side that represents that based on the definition. And we'll have to have some generic way of navigating that structure and querying that structure as well, because the server's then going to want to say, okay, I've got the move command to move to this exit, say here, northeast. I know the player, I got to know which room the player is in and whether that room has an exit associated with it called northeast. And if it does, then I got to look up that exit. Where does it go to? And then I got to put the avatar in that room. All right. And then whenever something enters or exits that room, I've got to broadcast to all the other avatars in that room those updates and those changes. Right. If a mob moves in and out, if an item is dropped, that sort of thing, all those changes have to be sent out to all the connected clients whose avatars are in that room. I wonder how we're going to do that. Yo, System Carl, what's happened? Yeah, it is pure text, for sure. And we're going to rebuild the muds of yore, but with Haskell and a little bit of Lua for users to make their games in. But yeah, it's going to be. I'm trying not to impose too much structure on it, but we need some conventions. I'm just looking at the design of like what would be a good way to structure this. So I found a Lua parser that I can now parse Lua code from Haskell so that you can write your component definitions. So when you start writing mobs and making your own mobs and programming them, you can define them in Lua files, like normal Lua code. We can parse that Lua code, interpret it into our definition structure. And then that hooks into the rest of the stuff we did for components last week, which allows us to instantiate those definitions with some values and create a live component, which is going to tie into the rest of the component system. So when you instantiate a new mob, you give it a template that's going to have this list of component definitions in it, and then you give it all the values to instantiate it with, and then we add it to the live database and start calling your system code on it to update it every tick. And that's how we'll do mobs. So mobs will be able to move from room to room, interact with players in all kinds of ways, however many ways you can do it. I mean, entity component systems are very, very flexible. And so, yeah, you'll be able to do that. But maps are what I think I should work on next, because I want to be able to connect to this server and log in as a character and see a map, see a room that I'm in, a place that I'm in, see a room description, see some things there, maybe a mob, maybe some objects, whatever, that sort of stuff. Okay, so let's go in simulation. Let's start scratching out some of this stuff in code. We're going to call it simulation space. Sure. Okay. So rooms are, I don't know if this is my mind just being like forced into a box from knowing MUDs and playing MUDs for so many years, but maybe we could get a little, maybe we could think outside of it a little bit. But the word that comes to mind for a unit of space in MUD is always room, because it's just the way they were defined once in the 80s when people were making these things. So I'm thinking maybe we should stick with that nomenclature, just because it's familiar, to me at least. So rooms, we're going to need some basic structure for them. Yes. Thank you, System Carl. Yeah, it doesn't really matter what we call it. It's just a contract for the mods. Yeah. Yeah, so we need, yeah, exactly. Exits, doors, whatever. That take us to another room. Yeah. So to represent this on the Haskell side of things, hopefully this is going to be not going to be too cray-cray. But maybe it will be, I don't know. We're going to need a room name. We're going to need a room description. Ultimately, I want to be able to make the descriptions like templates. I think that'll be much easier to manage. But for now, we'll just make it text. Then we're going to need a list of exits. Or it could be a map of exit names to exits. Let's put our usual EQ and show on there, and then make these red squigglies go away. Okay, and an exit. Typically they're like, the spaces are graphs, and the exits are two ways, like they're undirected. Right, so they have rooms that they attach together. Now, how are we going to represent that? Well, the rooms have a name, but the names would have to be unique. So we can have a room ID. And I don't know if I want to mix up IDs with the definitions of these nice little happy objects. Because I want to be able to parse a thing into a room, and when I'm parsing the definition on the Lua side into a room, they're not going to define the IDs. Yeah, display name uniqueness would be pretty annoying because then you'd have to live like, yeah, you'll have to enforce that globally too on the code side when interpreting the room map from the user Lua definitions and stuff too. So we'll just give the exit name. That's a little odd too. Like, it's kind of a two-way pipe. Entrance name? No. What if it's just exit name? All right, they have room. We have room. Very, very simple case. Room A, room B. The exit in A. Let me use a different color. Here. Connects B, but when you're in A, all you see is like east, say. When you're on the B side, all right, you're going to see an exit west. That'll take you to A. In that case, we don't really need... We just need a name and a place it goes to. As long as you define them properly, that should be enough information for our server when the user code asks us to move an avatar from A to B using exit foo, for us to look up in A, query the map, find A, or where the user is. Find this exit if it exists, and then if it does, follow this pointer, and I go, okay. And I query the map, find B, no. So, yeah, I think the exit just needs at least for display purposes, just needs the name. Now, the layer to this, so this will be a new type, at least for the moment. Now, the layer on top of this is that we want to be able to write these definitions in Lua and interpret and parse those Lua files to get a room object. But then we need to interpret that thing, right? So when I'm writing the Lua code for this room definition, we might write it like we did with components, where I could give the room name the room name maybe by assignment, or I might be able to just go straight to the table definition, because I want the room name to be nice looking. Right. Description. Some bushes. And what else do we have? That's an exits, list of exits. Now, what are we going to put here? Right. We could because we're parsing this on the Haskell side, we could just put variable names here of exits, and in another, say, room whatever .lua here. All right, we could have exit whatever .lua. Might also be a definition, but it could be like it could be a variable name. It would have to be unique as well. You know. At least on the Lua side. And we could do it like exit foo here. Alright, and so then when we're interpreting this and building up the Haskell data structure of your map, right, we could build up all your exit.luas. We would have a mapping of all these names. And then you can use your variables here to describe your exits, and it'll know which exit you mean. But then we have to know where the exit points. That's the trick. So we could maybe do following the same convention here. Use the variable names, maybe. Okay, say there's like something in there. An exit foo would be this one that points to B. We'll call it like goes to. Sorry, that's not the right syntax, but you know what I mean. Room bar. It goes to room B. All right. Maybe we could just stuff this in one giant map.lua file, and this is how you do it. And that way it keeps everything together. You kind of have to know what they are. We can like, or we could split it up into files if that might be more manageable. And then you put it all in a directory and just kind of load them up according to some convention. I don't know, System Carl. I think this might be the way to go. Alright, that way the names can be nice, pretty printed. But you can refer to it in other objects in your Lua file. And then the Haskell code interpreting this can still figure out what's what and what's where. And what do you mean when you could follow those references and look those up and construct the map. A reference file declaration in Lua later on. Well, like, what would that have? Like a bunch of these variable names, maybe? And just assigning them to a bunch of assignments or something? Yeah. I think that's pretty okay. All right. We wanted to map. Oh, way to combine files. Yeah, you could. It does. The Lua runtime does have a way to import other modules. So, like, The only thing is with this approach that I'm discussing here, like we did with the components at least so far, is that we're actually parsing the file, the Lua file, right into a Haskell data structure. So we're not interpreting the code. All right, that makes sense. All right, so this this thing lets you kind of like write the Lua code like this, and we can run parse definition on it. And we get a Haskell data structure just by parsing it. And that way we don't have to do any I/O. We don't have to like run it. But it is declarative, yeah, which makes things a little bit. Yeah, so like if we were to use the import stuff from Lua and treat it as a normal Lua file that we interpret, yeah, the way that would work, I could see that working, would be for you to construct that object in Lua, and we give you an API function for you to call, and you pass us your data structure. And then we interpret it that way. That's another way we could do it. All right, and that way you could write your code and split it up as we wanted to, and use the import functionality to import your code. Yeah, exactly. We could also, like with the declarative way of doing things, parsing the files, we could create our own compiler, and ultimately we'd have to at some point, because we'd have to compile all these exits and runes, and then we'd have to like interpret, make sure all the references are correct and work, and that the map is actually usable. All right. And in either case, in both approaches, whether we interpret some Lua code and get you to pass us a data structure, or you define a data structure and we parse it from a bunch of files and interpret it directly, we have to come up with an interface for us to look at a given map and query it and move things around into those different references. So we have to be able to resolve these things into like IDs that we can use at runtime. So we know where avatars are, where mobs are, things like that, and move them around. Cool. But I think we're approaching the end of the night, actually. So I don't know if we're gonna get into that so far yet, but let's just get space in a place where it models something like what we have here. So we have exit name, and we're gonna have goes to. Yeah, they could be infinitely complex, right? That's the risk we take with interpreting user code. Right, so we don't want to allow things that can break stuff. So the nice thing about the declarative approach, as I'm calling it, as we're calling it here, parsing the Lua files directly, is that we have a lot more control over those things. We're not interpreting any code. Well, we're not running Lua code in the Lua interpreter. Right, we're building up structures from parsing the source file itself. So you wouldn't be able to have like a Lua code that imports a bunch of modules, that does a whole bunch of stuff and then never returns to the server, for example. Right, we either parse it and you're good. So that's kind of a point in favor actually of doing the parsing approach, at least for the definitions of things. It'll be a different story for systems. So in the entity component system, when you're designing a mob, or you're designing your player character, your player avatars, and how they're structured, they're going to be an entity with a bunch of components, and then you're going to write a system that operates on one or more components. And that system is going to be pure Lua code that we're just going to hand off to the Lua interpreter and run it once a tick to update all of the entities that are live. Right? Update all the systems that are live, and those will change the entity states. Yeah, so if you write some terrible Lua code that crashes your server, well, sorry. Hopefully the Lua interpreter will crash and you'll get a traceback, something like that, but can't do that. But for definitions, though, I think it might be nicer to do it this approach, because then a bad definition will be easier to catch, and you won't have any side effects necessarily, uncontrolled side effects in that stage. When we're parsing definitions, like with the components and stuff, we do that. We can do the same thing for rooms, and it'll be easier to serialize. And it might give us some benefits when it comes to serializing persisting state. So, okay. Let's see, I'll commit this file, what we have so far. We gotta update our Cabal file and add it. And then we'll make a commit and pop this up. So thanks for hanging out with me tonight, folks. Friends, curious hackers, and other never-do-wells and doer-wells. It's been a pleasure. There we are. I do these streams about once a week on Tuesday evenings in the Eastern Standard Time Zone, about 10 after 8 in the PM. And you can give me a follow here on Twitch if you want to set up your notifications. You'll get notified every time I go online and do a stream. You can write it down somewhere, put it in your GCal or whatever you use. And if you're following me on YouTube, you know what to do there. Like, subscribe, leave a comment. Get notified when I put a new VOD up for my stream. Follow along with the development of Bakamud. And we're going to add Bakamud simulation space. Types, functions, and things for manipulating the game space, the simulation space. All the code for this project, it's called Bakamud. It's up on GitHub. I'm Agent Ultra. I'm Agent Ultra on GitHub as well. And a lot of the projects I make on this stream are hosted here. So you can give it a star, fork, a like, whatever you want. It's all good. It's going to be open source. It is all open source. Do what you want with it. It's just for fun and for learning and all of that good stuff. So check that out there. I'm also on the Fediverse, on Mastodon. I'm on the types.pl server, Agent Ultra. You follow me here for updates on this stream, various other things I'm working on and whatnot, and sometimes a little trash talking. I try to content warn anything that isn't like mostly tech related. I'm not always perfect, but you know, we give it a shot. And what else is there? Oh yeah, go to the link above my head, declarative.tv. There are a lot of other cool streamers doing things in languages like Haskell, but also other declarative programming languages like Erlang, maybe even Elixir, who knows. But they're all looking for an audience as well and some support, so go there, check them out. There's also a link to a Discord server there where we have a channel for this stream and for others to hang out, talk about programming, all that sort of good stuff. So you can check that out there as well. That's all I got for you tonight. Thanks again for tuning in. Appreciate it. We got a few viewers here, so let's go for a raid. Let's look for some raid action, and we'll find out what's happening. I think we're still live. My preview is a little off, but we'll find someone here. Level designing. Ooh. Let's go raid them. All right, so give them a follow and a like. Show them love. Thanks again for watching. May your monads be free and your types check. I'll see you next week. Peace out.